Okay, so if you're watching the video, you should have the handout reversing conditionals, independence, and yeah, just reversals in general in front of you. So we already did a problem like this the other day. First, we've got some data from Michigan, a bunch of elementary school students, 4th, 5th, and 6th grade. I guess elementary school, 6th grade there too. It's pretty common. So we asked them, what? What's your main goal in life? Kind of a heavy thing to ask an elementary school student, but yeah, I think it makes sense. Yeah, they told us about even how they sampled the students to pick. How'd they do that? Stratified. Do you guys think that stratifying was a good idea here?
Yeah.
Rural kids probably behave differently than like urban kids in a like inner city school versus, you know, a school like one of the schools in Pueblo. Most of those could be called suburban schools. Maybe not central. I don't know. None of those are really. Pueblo's not a big enough city to really count. Anyway, so we've got this data. So first they asked you to compute. Who can read this for me? The probability that they picked sports given that they're male. Very nice. Just hoping I didn't hear vertical bar. Nice. Okay. You can also say this in math. I mean, you could say the probability of sports such that they're a boy, but for us, given is a better way to think about it. So, okay. So our sample space is restricted to who then? The boys. How many of them are there? 227. How many of them picked sports? 60. What's the decimal? Okay. There we go. So you guys, read this one to me. Everybody. Given that they're a girl. So the sample space is now just the girls, or 251. Girls who picked being popular as their priority in life were 91. So what's that work out to? This is just kind of warming up, right? What is it? 36? Thanks, Logan. Okay, the next question you were asked was, are the events grades and girl, or in other words, you know, the events grades and gender, because that other event, boy-girl, only has 2 options, right? So are grades and girl independent? How can we show that? This is the big question. Well, I think we first want to look at the probability in this group of data of girl, or do we want to look at the probability that a student picked grades? What do you guys think? Because this is a formal independence test. You guys remember way back in Unit 1 I asked you about independence, but we didn't really have the tools to do that. Some of you guys kind of figured it out on your own. Actually, several people did, so I was impressed. But now you do have the tools to do that. The tool you need is conditional probability. We did this with 2A tables back in Unit 1. It was just, I didn't formally show you conditional probabilities yet, right? But I don't think we want to look at the probability of being female. We want to look at the probability that they picked grades. And we want to see if being female affected whether they picked grades. That's what's going to tell us if those are independent or dependent. Does that make sense to you guys? I hope so. We want to see if grades, being female, the condition of being female affected that. So I should be seeing if, what here? The probability they picked grades given that they're female, exactly, and see if those are about the same. Now, they don't have to be perfectly equal, but they should be really close if it's truly independent, right? So let's see, what's the probability of picking grades? What do you get for that? So we don't know this yet, right? We've got a big question mark on this equal sign. We don't know yet. That's what we're testing. So grades is
51.6.
Give me the fraction though, so everybody can see where it came from.
47.4.
I'm kind of in the way of one, but yeah, 247 out of the overall grand total, right? And then over here, it's just another one of these computations. We didn't do this one yet, did we? So females is the sample space now. That's our 251. And 130 of them picked grades, and now we can turn these into decimals to see if they're the same or not. What's this one? 50. Give me one more decimal.
7.
Okay, and this one was, we still don't know. This one, 51.79. Do you guys think those numbers are close enough to establish independence?
Yes.
So in other words, we could write a sentence that says, this is pretty strong evidence. That's really close numbers. So we've got strong evidence that, and I'm starting to train you to write this the AP way that they'll actually ask you once we're done with everything. So it shouldn't come as a shock. This is strong evidence that gender and grades are...
choosing grades.
You're right, Logan. I should be a little more particular about what grades means there. I could even throw in like another phrase, right? About like, and the kid choosing grades as their priority in life. Are independent events. 4. Help me make this better. Students, kids.
Michigan.
Yeah, there you go, Sean. I don't even think you could probably generalize this to all of Michigan, though. Like, it's where they got these kids from. They didn't tell us exactly, did they? They say where in Michigan? Yeah, so maybe it generalizes to all of Michigan. It depends how they set up that stratified sample. If they pulled it from all of Michigan, maybe we can generalize it to Michigan. But you could never imply anywhere on the AP exam, or on my exam, really, but I think the AP exam's dead on with this. You can never imply that some result applies to a larger population than it actually does, okay? We talked about that a lot. It's a very common mistake people do taking that exam, so. Okay, what else are we supposed to look at? Are the events sports and boy independent? What do you guys think on that? Well, let's rewind. So what are we checking here? We're checking to see if being a boy, or in other words your gender, affects whether you picked sports. So I should check the probability of sports and see if it's the same as the probability of sports given that you're a boy. Really, could I put girl in there and still check this same thing?
Yeah.
I think so. Probability of sports, though, is 90 people pick that. So that's going to be 90 out of the total. This one, we're restricting ourselves to the sample space of boys, which is 227.
And we already did that.
Oh, and we already did that. That was this one, right? Nice. So this is really just 26%. So it's that calculation right there, right? This one works out. Is this one 26% or really close, or what is it?
It's 18.82.
That's like a whole 9% or so different. I don't think these are independent. I think picking athletics as your priority is dependent on gender. Now you might be saying to yourself, well, that's not a huge difference, Mr. McGee. It's like 10% different. It's pretty different. Does it mean that like it's absolutely set in stone? No, but it means that there's a statistical difference between those. Okay? So let's look at the other side. So what's going on in that second example? It's controversy already? Is it because of the alcohol or what? Maybe. So first, you guys have read through it, right? It's the one about, so this is example 2, trees again. That's what I called it anyway. What's the question asking? I think it's a little bit tricky. On a lot of problems, when you're problem solving, like you got to first figure out what they're even asking you before you even attempt to do the problem. What are they asking us to do? I think it's a little bit uncertain in this one. What are they asking for? It says, what's the probability that a randomly selected college student with a binge will be a binge drinker who has had an alcohol-related car accident? I think that could mean two different things. We'll compute which of those two different things, And then I'm going to ask you guys to help me try to narrow down which one are we actually supposed to do, okay? So two different things. Anybody have some ideas? We want the probability of what? Being a binge drinker.
If you got
And, I heard Tyler say and being in an accident. Right? That's one possibility. They might be asking us that. The way this is worded, though, I think it's a little bit uncertain as to, it could be something else, too. Because I used that who in there, which kind of made it a little ambiguous for me anyway. Maybe you guys nailed it down right away, but what's the other option?
Given
Given.
What's the probability?
given
Yeah.
So let's just use a diagram to figure out these both. I mean, we might as well just calculate them both, right? We should be able to do that, and then we'll try to talk through which one. Maybe they don't even know what they're asking us, but they're two different things, right? They're definitely two different things, and we'll try to think about which one of those things is more valuable and maybe which one they're asking us if they really know. So, how do I calculate this? What do you guys think? Do I want to do a two-way table? Do I want to do a tree? Do I want to do a Venn diagram? What am I going to go with here?
Tree.
Well, it was called trees again. Not because I love the environment. I do. Who wouldn't? Except Republicans, apparently. I'm a Republican who likes the environment and stuff. That's tough. Yeah. Dang Republican Party. Anyway, we won't get off on tangents. So, what's my first event that I want to look at with these branches here? What do you guys think? Should we go binge or not binge? Okay, let's do it. What's the symbol? How can I write down? We haven't done this for quite a while. What's the symbol for the complement of binge? There's two different options. You can put a little bar on top. I don't like to use a little bar, even though that's a lot more common in math, actually. Because in this class, bar means average, yeah? So I'm going to use a little C for complement, okay? Binge or binge complement. And then this event that these tree branches are is what?
Accident.
Accident, no accident, accident complement. Okay. Why don't you guys try to fill in the branches, the probabilities on those branches while I talk to the small one. My understanding is 57. I don't want to say anything, but I didn't do stuff in physics class.
Okay, so all I do is this.
Oh,
No, yeah, it says straight out 44.
Okay, what's on these branches? Can you guys help me?
44% binge drink.
44% were binge drinkers, is that right? Trusting you guys to tell me if it's not right. And then they say 50, so that means 56% aren't. Wow, 44%. I guess so. It's college students, okay. All right, accidents.
alcohol related is 17%.
Oh, we're a little more uncertain, 17%. Under 17, I think that's right. Where did they say exactly for that 17%?
That means alcohol.
17% have been involved in an automobile-related accident. Okay, so then this one we should be able to get by subtracting. We get what? 83? Then they also told us only 9% of those non-binge drinkers have been involved in accidents, so that's what goes here. So this is 91. So how many outcomes do we have here total on this diagram? 4, of course. Okay, we could get those all. I'm just going to try to answer the questions that we have, though. So how do we get and? Probability of binge drinking and being in an accident. Where is that on my picture? Across the top, right? It's just that. Binge drinking, accident. Those both, that's only this branch. So this is going to be pretty easy to do. It's going to be just equal to 0.44 times 0.17. I think I got was 7% or so.
This would be.
Yes.
It said for 17% have been involved in alcohol-related accident, but it says 44% engage in binge drinking, 37% drink moderately, which would be counted to 56%. So,
Yeah, you could have split this into 3 branches if you wanted to. Yeah, I just decided like the really bad drinkers and the other ones because that's what it asked about, right? It's a good question. Sam raises a very good question.
Okay.
Like they asked really just about binge drinkers. So if you split this into 3 branches, you could get the same answers. It'd just be more complicated. It's a great question. Yeah, I mean, if they'd asked about the moderate drinkers, we'd have to split it into that, or we'd have to go moderate and other. Right? Good. That answers your question, right?
Yeah.
So what about this guy? Let's do that guy in a different color over here. Go green. So how do you get this guy? My sample space is now restricted. How do we do that on a tree diagram again? You can do this on any diagram, right? Venn diagram, tree diagram, contingency table. You can do these on all of those. Just some things are easier on some diagrams than others.
You have to,
They'd have to have been in an accident. So what branches should I be looking at?
the A's.
The top one and
The third one.
the third one down, right? This one and this one. So that's the sample space. This probability is equal to 0.44 times 0.17 plus 0.56 times 0.09. That's that branch and that branch, right? And we want the probability that they were a drinker, which is the top branch. So that's going to be like this. And you're just going to stick that guy in your calculator and see what pops out. I got 59%. So let's go back to the question one more time and see what they said. See if we can puzzle it out. So they said one more time. What's the probability that a randomly selected college student, so that implies anyone, doesn't it? But then it says, will be a binge drinker. I think that's still anyone who has had an alcohol-related accident, who's had an accident. So you can, sometimes it's best to chop words out of there, right? What's the probability a randomly selected student will be a drinker who's had an accident? What do you guys think? Are they asking for and or the given? I think they're asking like they're saying like that they're a drinker and they have an accident. The and is implied. I think they were asking for that. Which one of those is really a better question to ask? What's the probability they binge drink and had an accident? Or what's the probability that given they had an accident they were a drinker? Which one of those is a better question, honestly? The second one. The second one's definitely a better question. I think they asked us for this. They didn't really know what they're talking about. This is a much better question. This is a lot more informative, right? Because yeah, this involves a lot of coincidence and a lot of other variables. It hasn't been, in other words, like blocked. You kind of know what I'm saying? This is saying just focusing on those people who've been in accidents, how many of them were drinking? How many of them, not were drinking in the accident, that's not what this is saying, right? It's just saying, out of all the people who've been in an accident, how many of them were drinkers? Maybe the drinking was involved in the accident, or maybe not. Maybe it just messed up the lifestyle and made them more prone to being in an accident. You know what I mean? That's a much more telling statement. And notice, 59% of them. It's 59%. So this is some evidence, and I think it's probably pretty strong evidence. We need to learn some more technique before we can really write it down formally. But this is some evidence that drinking affects accident status, yeah? And not just like DUIs. This is just saying like that drinking too much can put you in danger. This is what this is showing, okay? I'll see you next time. Okay, so let's finish up that last example with tuberculosis. So can you guys help me set up the tree diagram? So we had one event being whether you got tuberculosis or not, right? And the other event was whether you, like the test said you had it or the test said you didn't have it, right? So we call that a positive outcome on the test or a negative outcome on the test. We're hoping for negative, yeah? So the tree, I think, should look something like this, yes? So we've got tuberculosis, we say TB. That's what it's commonly called. You guys know the other name for TB, the old school name? Starts with a C. It's called consumption. It was a really common disease like back in the 19th century, even in America. It's been weeded down to like the third world in Russia. There's still a lot of people in Russia that have it, so gotta be careful traveling in these places. Anyway, it's not even a huge problem in the third world anymore, which is good. Anyway, so we've got TB, and then we're going to go positive and negative. So did they tell us the chance of actually having TB basically in modern America? How many people end up with TB in modern America?
5 out of 10.
5 out of 10,000. That's still more than I'm comfortable with. But okay, so 5 out of 10,000 goes right here then, right? What's that as a decimal?
0.000.
3 zeros, Kinsey?
Yeah.
Okay. So then we know this, right? So this is 0.9995. So I think the other part was the challenging part of this question, just based on the way the information was phrased. And that's common, like you need to be able to translate in the real world. So the other two pieces of information they gave us are that the test is 99% effective. So that's why the person whose arm flared up in this scenario freaked out, because they thought, well, it's 99% effective. Shoot, I have TB. My life is over. I mean, your life's over, but it'd be a big problem. Yeah, so they freaked out, probably, legitimately, except they didn't understand probability that well, I don't think. I don't think the nurse did either here. So 99% effective, that's going to help us with one of these branches. And the other piece of information was that a false negative rate of 0.1% occurs. I'm going to start with the false negative rate. False negative, what's that mean? Okay, so falsely negative. Let's turn that around. Kinsey said, you actually have TB. And it's not like that's what you have to write here, but these are the ways that you should be trying to do stuff, especially in this class, is paraphrasing information and turning it into something else. That's why this class is going to help you do better on standardized tests like ACT, SAT, because that's the key to standardized tests, is rapidly rephrasing things into the easiest form possible. Yeah? Okay, so you actually have TB. Well, which branch are we on then? We actually have TB. But we tested negative. So we got that for our false negative. Then the other piece of information we had was that the nurse said the test was about 99% effective. So if it's 99% effective, which one of these is effective? You actually don't have it here. So if the test did its job, then this is what it tells you, right? So this should be 0.99. This is the percent of cases where the test didn't do its job. Okay? So I also want you to think, before we answer any questions here, which is the worst case scenario. We talked about that a little bit yesterday. Worst case scenario is you have it and the test doesn't show it. That's bad for you because you die or get really sick, don't get help. And it's bad for everybody else because you go around contaminating everyone. So which one of these is that?
Have TB, but you test negative. TB negative.
That one. Right? You have it, but you test negative and the test doesn't see it. So that's why when you take a TB test, if the first one comes up positive, they give you a different kind of test. And then that. But this person isn't in that scenario yet. They've just taken the first test and they have tested positive, so they're in one of these two branches, right? So they're scared. They're like, man, I hope I'm in here. I'm not in here. So the idea here is, what's the probability? Should this person be scared or not? What probability can we do to figure out how scared they should be? Well, what's the probability of actually having it given
The test positive.
that you tested positive. Yeah? Because they're scared because of that 99% number. But if we just tested positive, we have to limit the sample space. What should go down here?
Probability of test.
That one. And the other one where we tested positive. Where did I have too many 9s? I think it's
The other
right.
one was positive at 0.0.
It's right. There we go. Which one is up here that probability that you actually have tuberculosis is, of course, the top branch. You guys are going to have to help me with that one. I don't have it. What's that come out to? So the person that our arm is flared up, we're really hoping that this number is low or high. At the end of the day, I know. We're really hoping this number is low. Really hoping the chances of having tuberculosis since we tested positive is low on the first test. What's this come out to? Point 046? 48. You guys want to make sure? Confirm with John?
I got 0.0475.
Okay. Same kind of thing.
Yeah, so
Yep, few confirmations, there we go. So we're feeling a little bit better now because how much chance is there of us having it now that we've tested positive in this first battery of tests? Only 4.8%, so phew. There is only a 4.8% chance we actually have it. And now they're going to go run some more tests on us to see if that's true. Okay? See you next time.
Ooh, that's